Hey there, science enthusiasts. Today I'm diving into the fascinating world of typhoons, those massive swirling storms that can leave a trail of destruction in their wake. Ever wondered how these powerful forces of nature are born? Well, let's unravel the mystery together. First things first, let's talk about where typhoons form. These colossal storms originate in the warm, tropical waters of the Pacific Ocean. The key ingredient here is warm sea surface temperatures, around 27 degrees Celsius or higher. When the sun heats up the ocean, it causes the water to evaporate, creating a lot of warm, moist air. This is the fuel that powers a typhoon. Now this warm, moist air starts to rise. As it ascends, it cools and condenses into clouds and rain, releasing latent heat. This heat warms the surrounding air, causing it to rise even more, and a cycle begins. This ongoing cycle creates a low-pressure area at the surface of the ocean. And guess what? Nature abhors a vacuum, so air starts rushing in from surrounding areas to fill this low-pressure void. This inflow of air starts to spin due to the Coriolis effect, thanks to Earth's rotation. As the system gathers more warm, moist air and the winds strengthen, the storm begins to organize. The spinning mass of clouds forms a distinctive eye at its center, a calm, clear area surrounded by a towering eye wall where the most intense weather occurs. The eye wall is like the engine room of the typhoon, with wind speeds that can exceed 150 kilometers per hour. But not every cluster of storms turns into a typhoon. For a typhoon to form, the disturbance needs to be at least a few hundred kilometers away from the equator to experience the Coriolis effect strongly enough to start spinning. Plus, it needs little vertical wind shear, meaning the wind speed and direction shouldn't vary drastically with height. Too much shear can tear the developing storm apart before it can mature into a typhoon. Once the system is fully developed, it can travel vast distances across the ocean, driven by prevailing winds. As long as it stays above warm waters, it can maintain or even increase its strength. Eventually, when it hits cooler waters or makes landfall, it starts to weaken, losing its energy source. So there you have it, From warm ocean waters to the Coriolis effect and the intricate dance of air and moisture, typhoons are a masterpiece of nature's power. They remind us just how dynamic and interconnected our planet's systems are. If you found this deep dive into the birth of typhoons fascinating, don't forget to like and subscribe for more science-packed content. Stay curious, and I'll see you in the next video.